My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm an actual person and not a robot. And I'm very excited to have you all here because everything that you see in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium dome. If you're looking for those projectors, they're hidden just below that purple glow. And folks, the show that we're about to see right now is by far my favorite to do. This is different from all the other shows we've done here at the Morrison today. This one's called Tour of the Universe. And pretty much with Tour of the Universe, you're going to hear my voice for the next 30 minutes. It's going to be completely live as I fly you through the universe. And we're going to be starting off pretty close to the Earth, and we're going to zoom all the way out to the very edge of the known, to the edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where you are in space. But just a heads up, we are pretty small in the grand scheme of things. So just want to forewarn you. And before we get started with our show, folks, I do have to go over some quick house rules just so that we're all on the same page so we can have a great experience in the planetarium. There's a few of us in here. First off, there's no food or drinks allowed in, so if you manage to bring any snacks or drinks, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. And also, if you brought any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now's the time to turn them off, put them away for the next 30 minutes, as these can be very distracting, not only for you, but for the folks sitting behind you as well. We do appreciate your help, folks. And folks, if you need to leave early during our show, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where you're going to find the exits before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. But if you're a person that has trouble climbing the stairs, don't worry. Once the show's over, we'll have a staff member escort you to a lower exit, so just remain seated as the show's wrapping up. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, well, there's a really quick, easy trick to ground yourself. All you got to do is close your eyes and take in a deep breath, and your brain will remember that you're sitting in a planetarium in San Francisco and not flying across the universe, at least not more than the usual. Hee hee. But with that being said, it looks like we're ready to go. So invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth. We're going to be starting just above it. We can see the city lights all down below, but we're starting at this spacecraft right in front of us called the International Space Station, or the ISS for short. Now, a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around the Earth. And they conduct all different types of experiments up here that they're unable to do on the closer to the planet with a lot more gravity. Some of the different experiments that they'll conduct are things like, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? What happens when you try to spark a match in space? Does the flame act the same? Does that act differently in space? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan on living in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks enormous on our screen right now, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And also what's really neat is that the International Space Station is going really fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes. And it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this thing looks really far away from our planet, but the International Space Station is only 225 miles above the surface of our world. 225 miles? Ooh, that's not bad. That's like going from San Francisco to Santa Barbara, a nice little road trip to get you away for the family with the family for the weekend. So not too bad. And folks, 225 miles is as far as we put humans into space nowadays because traveling into space is quite costly. You got to build yourself a rocket ship or buy yourself one, and then you have to get your hands on a lot of rocket fuel. And then once you get your hands on all that rocket fuel to leave the Earth, then you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite expensive quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to slowly leave it behind and we're going to see it slowly disappear to the city lights down below. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see it as it disappears. All righty, everybody. We're now looking down at our entire world. And I do want to let you know, folks, that the space program that I'm using here in the planetarium is something that you can go home and download if you want to try it out and fly through space just like how I am. The space program that I'm using right now is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you can find the link where you can download this and fly through space. But just a heads up, OpenSpace isn't entirely finished. They're still working on it, so it's in its beta phase. And we may come across a few bugs and glitches here and there. If we do, I'll point them out. Hopefully we can look past them. And also, folks, it looks like we have a good data glitch right there. You don't see anything, folks. And also want to let you know that OpenSpace uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm it because it pulls information from geo satellites pretty much every day. So it needs a lot of processing power. But if you have a newer computer or a gaming computer, give it a try. It's a whole lot of fun. And if you're a person like me that doesn't want to download anything, you just want to go to a website and fly through space, well, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes in your favorite search engine, and you don't have to download anything. You can fly through space just like how I am. Looks a little bit different, but just as fun. So we have OpenSpace Project and NASA's Eyes. But now that we got a good sense of what we're using here, let's make our way over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, folks, but that was kind of a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun as well. They got to play some golf up here as well. But again, last time we sent humans to the moon was a little more than 50 years ago, 1997 or 1979. But don't worry, folks. We humans are planning to make a return trip back to the moon in the next few years, thanks to NASA's new space mission called Artemis. Pretty much, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to live out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we're going to be doing that. And folks, our technology has greatly improved in the last 50 years. So we're able to conduct a lot more science in a much more compactable size. And also what's really neat about Artemis is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout the moon. And again, our technology has improved greatly, so we want to expand out. And one place that we want to definitely set up a lunar base is the south pole of the moon, because we've come across ice there, and ice could be very useful for setting up a base. You can melt it, you can pass electricity through it, you can separate it to its basic elements, hydrogen and oxygen. So that could be very useful for setting up a base. And what's also really neat is that Artemis is going to have a space station orbiting around the moon at all times, kind of like the International Space Station that we just saw. So if anything was to go wrong while these astronauts were on the surface of the moon, they can launch off that space into that space station where they would be safe. But again, we humans should be returning to the moon in the next few years thanks to Artemis. So look out for any news about that. And folks, here on Earth, when we look up at the moon, sometimes the moon feels really close to us. It feels like you can reach out your arms and touch it, especially when it's close to the horizon. But the moon is really far. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. He. And folks, from here on out, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind boggling speed of 187,000 miles per second. That's roughly 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the earth and their orbits as they start to slowly disappear. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. So let's zoom on out and get a much greater sense of where we are. And now, folks, our nearest star, the sun, is coming into view. So here comes the sun. Do 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 do. I know it's a bad joke. And folks, our sun is incredibly far away from the Earth. It's about 93 million miles away from our planet. So again, we're the third rock from the sun. 1, 2, 3. That's us. 93 million miles between us. But in terms of light speed, that's not too far. In order for sunlight to cross that distance, it only takes sunlight about 8.5 minutes at the speed of light. Whew, that's really fast. And now that we have a nice sense of a bird's eye view of our solar system, let's get a refresher course of what's in here, shall we? So right in the middle, we have our sun, the star. There's our star, the sun. And the closest planet to the sun, we've got Mercury. Then we have Venus, Earth, and Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if all the asteroids were highlighted. There is a lot of them. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the biggest one of them all. Then we have Saturn. And then after them, we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. Yeah, so the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. And what you're mostly going to find out here are icy asteroids and short period comets. Comets that don't stray too far away from the sun. They have a nice little short period like that. But in 2006, we found more than 400 objects out here in the Kuiper Belt region. And that's the really cool thing about it, because as our technology improves, our telescopes get better, we're able to find much further, much smaller, dimmer objects way out here. So as our technology improves, maybe in the next 5-10 years, we'll be finding more objects in the outer part of our solar system in our own backyard, which just sounds so cool. I can't wait to see what else we'll find in our own neighborhood. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some of the many different spacecrafts we sent out to explore our solar system in the 1970s. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. Whew, 5 hours. Not too bad. But folks, let's leave our planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And we are still going. So again, our star system's right there in the middle. Alpha Centauri is going to be the one on the right-hand side. We can kind of see a star moving closer to us. That's Alpha Centauri. So again, 4 years at the speed of light just to get to the next star system. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting a spacecraft today, left planet Earth, make your way over to the next star system. It's going to take you about 8,500 years to cross that distance. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we are now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. And this first began in the early 1930s with strong radio waves, early television, radar signals, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding on screen some mini markers. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found 5,000 exoplanets confirmed just in the nearby vicinity to us. 5,000 other worlds besides our own. Whew. And that 5,000 exoplanet number is going to be increasing as the years continue, because we have space telescopes where their whole purpose is to find as many exoplanets as possible. They're constantly scanning the night sky. In fact, if you look in the back right-hand corner, you see all those exoplanets right there. That's just from the telescopes looking in that one section of the night sky. So they still have a lot more scanning to do. So that 5,000 number, that's going to be going up. But to answer the question if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now, so it's going to be a few years. So they need to do the drawing board, they got to build them, they got to launch them into space and do the scientific method. So we got quite a while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system. Let's say this one right here on the far left. We find an alien civilization somewhere towards the middle. We shoot them a text message. We say, hey, we live here. Take 60 years to get to them. They listen in, answer back another 60 years. Whew, folks, that is a 120-year conversation in the making. And I could barely wait for a text message from my friend. But of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I'm going to put away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. Alrighty, folks, we're looking down our Milky Way Galaxy, and can anybody see their house from here? Just kidding. And folks, our Milky Way Galaxy is quite large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a good distance. And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way Galaxy, I want to show you what it looks like from a sideways perspective. When we spin on over to the side, you're going to notice that we live in a flat spiral disk of the Milky Way. So it pretty much looks like a big flat pancake. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, we like to point our telescopes galactically north and galactically south. And also, since we're here, when you look up at the night sky, you probably heard someone say, hey, look, you could see the Milky Way. What you're seeing in the night sky is the Milky Way plane, folks. So pretty cool. But the Milky Way galaxy is only one of many, hundreds of billions of galaxies that comprise the known universe, folks. So now in this giant leap, every single point of light that you see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we continue zooming out, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster towards the bottom, some over here to the right. We can see very few galaxies towards the top, or no galaxies at all, those voids. You can kind of think of galaxies like people. They like to hang out together, or they like to avoid each other. And also, we've zoomed so far out now, folks, that this picture that we're looking at represents the closest 30,000 galaxies to us over a space over 300 million light years across. Whew. We got to give thanks to Brent Tolley, who's an astronomer that worked at the University of Hawaii, who compiled this amazing representation thanks to the work of other astronomers working beside him over decades of time. So big shout out to Dr. Brent Tolley and his crew. And since we're all the way out here, folks, I do want to show you the brand new James Webb Space Telescope image. So the first image that the brand new James Webb Space Telescope released, which is this right here. What we're looking at is the James Webb Deep Field image. And folks, it is beautiful. I love looking at this image so much. This picture that we're looking at occupies a really small section of the night sky here on Earth. If you were to pick up a sand grain, lift it arm's length away from you, that's about how big this frame of a photo it is. It fits inside that tiny sand grain. And we're seeing hundreds of galaxies all in this photo. And what's even cooler is you can see gravitational lensing. So right in the middle of this image, there is a galaxy cluster. And these galaxies are very heavy and they cause space and time to warp, distort it. So they cause the background galaxies to distort, which kind of looks funny. They kind of look like smudges of galaxies. So we can see this nice smudge of a galaxy on the bottom left around this bubble. And then we can see a nice one towards the top. Some folks are referring to these smudge galaxies as space bacon because it looks like bacon in space. He. And also, the photo that we're looking at is quite impressive because the James Webb Space Telescope was able to produce this image in only 12 and a half hours of exposure of taking a photo, compared to the Hubble Deep Field image, which took 21 days. So, folks, our technology is improving, and I can't wait to see what other images the James Webb Space Telescope will be releasing. But let's continue on with our tour of the universe, because now we have automated systems that are mapping even the most distant galaxies, folks. We're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And also, our universe is not shaped like a bow tie or a butterfly. Remember when I mentioned that we live in a flat spiral disk of our Milky Way galaxy? Well, if you were to line up our galaxy just like so, our galaxy would line up just down the middle right there. So again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. But astronomers still want to look through the Milky Way plane, and they were still able to find galaxies, these purple dots right there. And you'll notice that they were still able to find those galaxies, just not as far and not as many. Pretty much, we have to wait for our technology to improve. And once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. But folks, it looks like we're running drastically low on our tour of the universe. 30 minutes is just not enough time. So let's continue pressing on, because now we're going to be encountering these really distant, far away objects known as the quasars, which are these orange dots at the very edge of the large-scale structure of the universe. We can see them on the left. We can see them on the right. And quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, what the quasars are viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. So Here we are, folks, at the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo. Instead, this is a temperature density image where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny, and they vary no more than 1 part per 100,000. But these really small differences eventually gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. Ooh. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's make our return trip back to planet Earth, find this nice entry point through all these galaxies and quasars, and let's head home, folks. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I'll remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that. We're now entering our Milky Way Galaxy. We're heading straight for that radiosphere. And of course, we're making our way downtown, walking fast faces past them. We're homebound. Dun-dun-dun-dun-dun-dun. And folks, we are now entering our solar system, passing the Kuiper Belt and the spacecrafts we sent out in the 1970s to explore our solar system, and making our way to the third rock from the sun, our homeworld, planet Earth, the only place we humans have ever lived and occupied. All the people we know, everybody we learned in history, all lived on this one planet. And we're now about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank you all for stopping by and watching with me this afternoon. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound. And that's all for now, folks. Thanks for stopping by.